you have some of these memorized by now. If not, don't worry, we're going to be referring back to them as we're solving these problems. So for question 1, practice. F at x is equal to cosine of x squared. Take a second if you'd like to try it on your own. Pause the video. The rule says that f prime of x is going to equal to, well, negative sine of x squared. We keep that the same, we don't touch it yet. But then the chain rule tells us that we're going to multiply this whole thing by the derivative of what's inside the bracket, right? So that's 2x. So simplified, that's negative 2x sine of x squared. Okay. Question 2. We have sine of 3x squared. Okay, well, again, the rule tells us f prime of x is going to equal to cosine of 3x squared. We leave it the same. All we do is just apply the trig transformation there. Great. And then we multiply by the derivative of what's inside the bracket. Well, the derivative of 3x squared is 6x. So again, we can put that in front just so it looks more appealing. So 6x cosine 3x squared. Okay, question 3. F prime of x. Well, this is a constant multiple rule, right? Which tells us that we can just put the 2 at the front and then just take the derivative of this function here, cosine of x. And we know the derivative of cosine of x, using our rules, is negative sine x. So, negative sine of x. And just to make this comment, the chain rule will tell us to multiply this by the derivative of what's inside the bracket. Well, the derivative of what's inside the bracket is just 1. So it's redundant for us to write just 1. It's really redundant, so there's no point. If you'd prefer to, you can. It doesn't really make much difference. I choose not to. Okay, question 4. Same thing. So we have this constant multiple rule, so we're going to put out the 3 in front and not touch it. And we're just going to focus on this right here, sine of 5x squared. Okay, so that's going to be, based on the rule, cosine of 5x squared. And then we're going to multiply that by the derivative of what's inside the bracket, meaning 5x squared. So the derivative of that is 10x. Now we can simplify this a little bit further by multiplying the 3 and the 10x. So 30x times cosine of 5x squared. Okay, question 5. So here we're going to have to take into account that we're dealing with a product rule. I'm just going to move this a little bit further. Great. So we have function 1, function 2. The rule says 1 times 2 means the derivative is 1 times 2 prime plus 2 times 1 prime. Okay? So let's solve for this now. F prime of x is going to equal to, take the first thing, multiply it by the derivative of the second thing. Well, the second thing is sine of x cubed. So cosine of x cubed multiplied by 3x squared, which is the chain rule, plus sine x cubed, the second thing, and multiply that by the derivative of the first. Well, derivative of x plus 1 is just 1. And that is the full derivative of that. Okay, now we're playing along with tan. Let's just remind you for number 6 that the derivative of tangent is secant squared of u times du dx. So secant squared u. Okay? So for 6, same idea. We're going to be using the product rule. So f prime of x is going to equal to the first thing, 4x squared plus 2, multiplied by the derivative of the second, which is 3 secant squared of x squared multiplied by the derivative of what's inside here, the bracket, which is x squared. So 2x plus the second thing, which is 3 tan of x squared, multiplied by the derivative of the first term, which is 4 times 2, because we're bringing down the exponent, 8x, and the derivative of 2 is just 0, so 8x. Okay, I hope you're getting the hang of these. Let's take a look now at 7, 8, and 9. I'm going to try to keep these rules on the board. Okay, so number 7, we have product rule. Again, term 1 times term 2. So take the first term, cosecant of x, multiply it by the derivative of sine of x, which is just cosine of x. Add the second term, sine of x, multiply by the derivative of cosecant x. And cosecant x, right here, is going to be negative cosecant of x times cotangent of x. Now, again, I'm reminding you, when we just have that singular x, the derivative of that is just 1. So it's redundant for us to just write down 1, but the chain rule still applies here. We just don't really write it out. For extra practice, let's actually simplify this. Let's remember that cosecant of x is just 1 over sine x. So we're just going to multiply that by cosine of x plus sine of x multiplied by negative, again, 1 over sine of x, which is cosecant. And then cotangent of x is just cosine of x over sine of x. And these are trig identities, right? This is something that you might have covered in class before. If not, check out my other videos as well. So again, just for extra practice, we can simplify these. So we have cosine of x over sine of x plus, so we have that sine of x times negative cosine of x, and this is just simplifying everything now, over sine squared of x. So you should start noticing something now. Cosine of x over sine of x is just cotangent of x. And here we have a sine of x that cancels out. We're left with 1 at the bottom. So minus cosine of x over sine of x, which is again cotangent of x. So cotangent of x minus cotangent of x is equal to 0. This is some fun practice for us. Okay, number 8. Again, first and second, so f prime of x, take the first term, 4 cotangent of x squared, multiply by the derivative of 5 cosine of x, which is negative 5 sine of x, plus the second term, 5 cosine of x, multiplied by the second derivative here. So we have 4, derivative of cotangent, notice, is negative cosecant squared. Okay, let's remember that, negative cosecant squared. So 4 times negative cosecant of x squared, and cosecant itself is squared. Okay, to clarify what this means, it's just saying cosecant of something here and all of this squared. When we have that 2 over here, it means we're multiplying the actual function, not what we're plugging into the function. Great. Yep. And now we're multiplying it by what's inside the bracket, which is x squared. So the derivative of that is 2x. Okay, for number 9, we need to know what secant is. So if we take a look over here, the derivative of secant is going to be secant of x times tan of x times du dx, right? If we have a function, in this case we do, so the chain rule will apply. So f prime of x is going to equal to secant of x times tan of x. So the derivative is going to equal to secant of x cubed plus 2x times tan of x cubed plus 2x. And that, now we're multiplying it by the derivative of this repetitive thing in the bracket, right? So 3x squared plus 2. Alright, well done. See you in the next video.